Yesterday we focused on properties of quadrilaterals, and today we're going to focus on classifying quadrilaterals. This is the anchor chart that's hanging in the classroom. Each of the different descriptions and words need to be committed to memory. If something has 4 sides and 4 angles, we call it a quadrilateral. 2 pairs of parallel sides is a parallelogram. 1 pair of parallel sides is a trapezoid. If it has 4 right angles, we call it a rectangle. If it has 4 congruent sides, it's a rhombus, and if it has both 4 right angles and 4 congruent sides, then we can consider it a square. If I give you the description of the property, you should be able to tell me which quadrilateral it is. If I give you the quadrilaterals, you should be able to tell me what property it has. For example, if I said, name something that has 1 pair of parallel sides, you would immediately think trapezoid. If I said, what's something specific about a rhombus, you would be able to tell me that they have 4 congruent sides. One of the ways to classify our quadrilaterals is using the family tree. So, amongst our family tree of quadrilaterals, you have 3 different types of quadrilaterals. You either have trapezoids, parallelograms, or kites. The 3 different types of quadrilaterals are broken down by the number of parallel sides. If it doesn't have any pairs of parallel sides, it's considered a kite. If it only has 1 pair of parallel sides, it's considered a trapezoid. If it has 2 pairs of parallel sides, it's a parallelogram. The quadrilaterals we'll be working with will either fall into one of those 3 categories. No parallel sides, kite, 1 pair of parallel sides, trapezoid, or 2 pairs of parallel sides, being a parallelogram. Okay. Now, the kite we're going to leave just as a kite. Trapezoids have 2 different options. You can either have right trapezoids or you can have isosceles trapezoids. Isosceles trapezoids is what your SOL will focus on. The isosceles trapezoid showing that these 2 sides of the non-parallel bases are congruent. Kind of like an isosceles triangle has 2 congruent sides, an isosceles trapezoid has 2 congruent sides. Okay. The right trapezoid isn't something that the SOL will focus on, but it is a name of another type of trapezoid. The parallelograms are the ones most frequently referred to. Okay. If it's a parallelogram, meaning if it has 2 pairs of parallel sides and it has 4 right angles, it gets to be called a rectangle. If it's a parallelogram with all congruent sides, it gets to be a rhombus. If you take these 4 right angles and these congruent sides and put them together, you get the square. Okay. This is why a square is a special kind of rhombus, because a rhombus has to have all equal sides, and a square does. A square is a special kind of rectangle, because a rectangle has to have right angles, and a square does. So all of your squares are rhombi, and they're also rectangles. But your rectangles and your rhombi aren't necessarily squares. This is an example of a rectangle that is not a square. This is an example of a rhombus that is not a square. Okay. So sometimes shapes can look like other shapes, and only sometimes they work, and other times they definitely work. The square is always a rhombus. The square is always a rectangle. A rectangle is only sometimes a square. This is a rectangle that looks like a square. This is a rectangle that does not. Another way to organize the information is with a Venn diagram. Earlier I said that quadrilaterals are broken down into 3 main components. The kite, which doesn't have any pair of parallel sides. The trapezoids, which have 1 pair of parallel sides. And then the parallelograms that have 2 pairs of parallel sides. Again, notice that the kite is all on its own. It's all that we have. In the trapezoid circle, we have another inner circle, which is the isosceles trapezoid, because the isosceles trapezoid is one of the types of trapezoids. In the parallelogram circle, which actually isn't so much a circle, looks more like a rectangle, you have rectangles, squares, and rhombus. This rectangle circle, or oval, is showing that both the square and the rectangle are types of rectangles. this loop is showing that both the square and the rhombus are considered squares. If you put the rectangle and the rhombus together in this overlapping part, that's how you get the square, because the square has right angles from the rectangle, the square has congruent sides from the rhombus. All three of these are types of parallelograms because they all have parallel sides, and in fact they have two pairs of parallel sides. Common mistakes. This green figure over here is a rectangle. It's a rectangle if it looks like this. It's a rectangle if I turn it this way. What makes that shape a rectangle is the fact that it has these four right angles. The two pairs of parallel sides makes it a parallelogram. If it's a parallelogram with four right angles, it's a rectangle. It doesn't matter which way I twirl it or spin it, it is a rectangle every single way. This shape over here is a square. I know it's a square because it has two pairs of parallel sides. One pair, two pairs. It has four right angles, and it has four congruent sides. However, for some reason, when I take that square and I turn it this way, people seem to think that now it's changed from a square to a rhombus. That shape is still a square. It's still a square because it has four congruent sides and four right angles. Whether I have the shape this way or this way, it is still considered a square. Now that square is also considered a rhombus because of the four equal sides, and that square is also called a rectangle because of the four right angles. But turning the shape doesn't make the name of it change. It is in fact a square. The other mistake that's often made is with this one over here. People see that purple one, and when it's turned sideways, they see it as a rhombus because it has four congruent sides. It doesn't have four right angles, so this is a rhombus that is not a square because it doesn't have the four right angles, but it is in fact a rhombus. If I turn it this way, sometimes people want to call that a diamond. There is no such geometric shape as a diamond. If you ever learned a shape to be called a diamond, erase it from your memory. You should have never learned that it was called a diamond. It is now and forever will be a rhombus.